Gosh, maybe solve this using trigonometric, these problems using trigonometric substitution.
Here's the appended, what is it? The appended image. This is the way to solve using trigonometric substitution. So basically anything of the forms, you just substitute it as this, just like that. So we will see in the later example the mean also. So just trigonometric integration by inspection. Nice. So anyway, so first let's do the substitution so we can see what goes out, what comes out of this when we do this. So when we substitute, what happens exactly? So let's start. So substituting x equals a sine theta into this. So that's a cosine theta. And then if we substitute a tangent theta into x for this, that's a secant theta. And then finally, if we substitute this a secant theta into this equation, a tangent theta. These are the only possible forms of any sum or difference of squares. So it's already there. By the way, it's oops, here. Here. So this is the first problem. Mhm. So first let's assign x and a. So once we complete the square and do everything. So once you complete the square, you can assign x. X is the term with x, of course, and then a is the remainder from the completion of the square. So they need to set it as 1/2 secant theta from the previous formula. And then we can already remove the 1/2, simplify it, and take out the 2. So now the tangents can be cancelled and we get cosecant theta. So if you don't already know, this is the integral of the cosecant. I don't know how this is derived, but this is the integral of the cosecant. Natural logarithm of cosecant minus cotangent. Then so we can simplify this further. Should be the answer should be in terms of x. We can make a right triangle with the angle in question. So if we set adjacent to 1, because we don't know anything, we can just set it to 1. Okay. So x we just use this assignment we did. So this is x and then we assigned 1/2 secant theta. Then secant theta is equal to 2x minus 5. So that means hypotenuse over adjacent, which is 1. So that's hypotenuse. So that's just 2x minus 5. So now we can solve for the opposite by using the Pythagorean theorem. Simplifying this, we get, so therefore this is the opposite. So now we can easily find cosecant and cotangent because cosecant is 1 over sine or hypotenuse over opposite, and then cotangent is adjacent over opposite. Okay. So from the figure, tangent is and cosecant is adjacent, opposite, hypotenuse, opposite. So I've already labeled which is width. So now we can already substitute. And simplify. This form was easier, but this is the preferred answer because it's in terms of x. So we can't do anything further, I think, because x squared minus 5x minus plus 6 is not a perfect square, so we cannot simplify further. That's problem number 1. Then we can actually simplify this further by using the properties of the natural logarithm. So since x squared minus 5x plus 6 is not a perfect square, it cannot be square rooted, but it can be factored. And we can use this to separate the entire fraction. So we separated the fraction by using the factors. And then we can just use the properties of the natural logarithm. And we have switched the sides and removed the coefficient because it's irrelevant. So that is for problem number 1. Final, most simplified answer. This is problem number 2. So here, what's problem number? It's in the form a squared minus x squared, so we need to use a sign. Okay. So we have expressed x in a sine theta. So a is 3 because 9, the square root of 9 is 3. And then the top is of course the derivative of the derivative of sine 3 sine theta. So that's 3 cos sine theta. So we just expanded the 9. So we can factor the 9 out because it's again irrelevant. We can just remove it out of the integral later. Okay, so now the 9 has been pushed out. And 1 minus sine theta sine squared theta has been already simplified. And we have square rooted the cosine squared theta that comes out of it. And then now we can cancel the 3 cosine theta on both numerator and denominator. But first, we need to know what sine squared theta will be and all of the other trigonometric functions. So we know that x is equal to 3 sine theta, so we can express sine theta as x over 3. We can make a right triangle, very simple. So 1 is x over 3. And then, so x is the opposite and 3 is the hypotenuse. That also works, but in this case, we'll be just using x over 3 as the opposite. So cosine is equal to 1 minus, we will use the Pythagorean theorem for cosine. That's what you get. So cosine is equal to 1/3 square root of 9 minus x squared. So cotangent is just cosine over sine. So that's cotangent. And then this is the integral of the cosecant square theta. That's negative cotangent, I think. Yes, see, so negative 1/9 cotangent theta. And then we just substitute this. Ta-da! Okay. So this is problem number 2.
Right?
Mm.
By the way, these problems were given by Sir Paul Lopez de Jesus.
Just wait for the jumper to load. Okay, I think it's loaded already. Mm-hmm. Maybe a few more tries and then clicks. Mhm. 7. There, away. Mhm. Wait while I just wait. I'll just pause share for a few seconds. Mhm. There. This Scrambled is timed out. So, anyway, so there. We revert my changes. Now it should show up. So, after I was able to recover I was able to unsync the changes. So now the Jamboard is back. So for number 3, this is the equation. And we are asked to find the original equation. This is the third derivative, and we're asked to find the original equation. So we can use the already given information, and then we can find third constant. We can find we can use our information about the slope, which means the derivative. This is the first derivative, and we can get the expression and use what we got earlier, which is C3 equals 5, find C2. And that C2, C2, okay. Anyway, that C2, we will find we can use our knowledge that it's an inflection point. So it means that the second derivative is 0. And we can find the equation again of second derivative, which means we can find C1, and we can finally complete our third derivative, which means since we already know the third derivative, which is -6, we can plug in into our original function, and we get fx is equal to negative x cubed minus 3x squared minus 2x plus 5. For the final problem, number 4, we're going to do the same thing as number 3, except this time it's already a quadratic. So actually, it will still be the same. There's a double integral, double derivative here. So we can already list down what we know and get the first integral. Ano, the double integral sort of integrated 2 times successively, and we use the other piece of information we know that the derivative is 1 to get C2, and we can substitute that and find C3. So we can already find the derivative. So we only need to find C1. Since we already know, actually we don't know yet. So we can differentiate this again. So we can express it into our already known expression. So because of this, we can find C1, which just turns out to be that C1 is just 0. So we can finally get our wanted expression by plugging in all that we know. So here we go. It's fx is equal to x to the 4th over here. The 4th plus x cubed minus 2x squared. C1 is 3, C1x, C2, which is 4. Okay, that's it. So this is QED. So this is for number 6.
Thanks
Thanks for watching.